Hello students, welcome to another lecture of Random Process and Information Theory, Unit 4. So, in the previous lecture I have discussed about properties of autocorrelation function. Now I will try to give the proof of some of the properties of autocorrelation function. We know by the definition of autocorrelation, by definition we know that R of tau is equal to expectation you know it's nothing but mean of t and t minus tau. So you always remember that expectation of x of t and x of t minus tau of a random process x of t will give you the autocorrelation function. Now try to understand like this, that these two random processes of the same random process x of t at two different intervals t and t minus tau. The difference between the time intervals of t and t minus tau should be always tau. That means the random autocorrelation function, it is dependent on the time difference of the two of the random process at two different time intervals. So you can say t minus tau. So t minus t plus tau, this and this cancel. So I can say time interval difference between x of t and x of t minus tau is tau. So you can say r of tau will be always dependent on tau. Similarly, if you have, as discussed previously, t1 minus t2, this will be also dependent like this, x of 0 t2 minus t1. So you can say your autocorrelation function, it's always dependent on the time difference and not on the origin of the time. So that's one of the most important property you should remember. Now starting with the first property of this autocorrelation function. First property is that r of tau is an even function of tau. Now I will try to prove this property. So starting with the proof, we know that r of tau is equal to e x of t into x of t minus tau. Got it? Now try to put, I will put minus tau, instead of tau in equation first. What you will get? R of minus tau will be equal to e x of t into x of t plus tau. Got it? Now try to understand this point. You know that this will be also equal to x of t plus tau, and this will be equal to x of t. Why? Because x of t is a stationary random process, and for stationary random process x of t plus tau will be equal to x of t. Similarly, its density function will be independent of time. This random process will be also independent of time. Its mean will be constant, because when mean of the random process which is stationary is independent of time, so mean should be also constant. That you have to remember this. So that's the reason, because I have put x of t equal to x of t plus tau from this. Similarly, x of t plus tau will be equal to x of t. So our equation then becomes x of minus tau equal to expectation of x of t plus tau and and x of t. Now try to understand. So I can say that r of minus tau is nothing but expectation of e x of t plus tau into x of t. Let I put t plus tau equal to t2 and t equal t1. So the difference of the time interval of the same random process t2 minus t1 is t plus tau minus t cancel tau. So I can say this random process x of t plus tau and x of t, the time interval difference between these two is tau, which was the case previously discussed here, r of tau. Here the time difference between these two is tau. Here also the time interval difference between these two, between the same random process at different time intervals, is tau. So I can say this is nothing but r of